is a very valuable type of oil due to its unique aroma. The oil is extracted from the fragrant resin found in the agarwood tree trunk. The formation of resin can be stimulated through natural infection of a consortium of microorganisms, chemical induction, and or artificial wounding. The unique aroma and the quality of the agarwood resin and oil are contributed by the presence of the certain chemical compounds. Sesquiterpenes has been reported to be the main active components that play important roles in giving the aroma and pleasant odor at the agarwood. However, there are many other chemical compounds in the agarwood resin and oil. Agarwood primarily produced from Aquila malacensis. Other members of the genus that are usually harvested are A. crasna, A. subintegra, A. agaloka, and A. sinensis. In this analysis, the chemical compound of the agarwood oil from A. malacensis and R. subintegra were conducted. The former is a local species found in Malaysia which has superior quality of resin and oil. The latter, with faster growth, is more common in Thailand and Cambodia. The characteristic of aroma help in identification and authentication of agarwood as well as determination of its quality.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Najwa binti Arif, metric number 2020, footstep number 14. So I am going to continue the presentation with pointing out the objective of this analysis. So the first objective is to learn how to handle and identify various chemical compounds using gas chromatography mass spectrometry, or we call as GCMS. The second one is to analyze different species of compound chemical of agarwood by using gas chromatography mass spectrometry. And the last one is to determine the characteristic of aroma between species in order to identify the authentic of agarwood.
For sample preparation, there are three types of agarwood oils produced using hydrodistillation technique, were obtained from different sources. The sample were labeled as sample A, sample B, and sample C, respectively, like shows below. The essential oil were diluted in hexane 5% prior to GCMS analysis. GCMS analysis were performed with a gas chromatography system with MSD quadruple detector 5975C. Separation of analytes by gas chromatography was carried out using a Hewlett Packard HP5MS silica capillary column. The analytical conditions for GCMS are listed in table. Lastly, the peaks from GCMS were detected based on the total ion chromatography, TIC, and mass chromatograms, and further identified using National Institute of Standards and Technology, NIST 2008 Mass Spectral Library.
Based on the analysis, this is the result of 3 samples of agarwood oil from different sources that show some variations in GC profile and chemical components. Figure A is the sample of malacensis from Malaysia. Figure B is the sample of subintegra from Thailand, and sample C is the mixture of the two compounds, which are malacensis and subintegra from Malaysia. The label peaks with 1, 2, and 3 have their own name, which is 3-phenyl-2-butanone, number 2 is the alpha-cubene, and the number 3 is glubolol. The x-axis shows the amount of time taken for the analytes to pass through the column and reach the mass spectrometer detector, whereas the peak show correspond to the time at which each component reached the detector.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal Munib bin Muhammad Nasir. My matrix number 2020626456, and I will continue our presentation with discussion. A total of 107 compounds were identified from the 3 samples of agarwood oils. There are sample A, sample B, and sample C. 55 components were identified in sample A, which contributes to the largest portion of the total compounds. Meanwhile, in sample B and sample C, there were 35 and 37 compounds identified respectively. There are also about 20% of the compounds identified were aromatic and sesquiterpenes, which have been revealed to be the main active compounds of agarwood oils. These main active compounds play important roles in giving the aroma and pleasant odor of agarwood. 3-phenyl-2-butanone and alpha-cubene, which is a waxy herbal odor type with medium odor strength, were commonly identified in all 3 samples of agarwood oils. Common occurrence of 3-phenyl-2-butanone was observed in all agarwood oil, or the scientific name is Aquilaria malaysiensis, obtained from different sources in Peninsular Malaysia. In an earlier study, benzyl acetone was also found to be major compounds found in Aquilaria malaysiensis. In sample B and sample C, globulol, or the IUPAC name 1147 tetramethyl dikehydro-1H cyclopropyazolone for all was identified. There were also 11 similar compounds identified from sample A and sample C, but not in sample B. Most of these compounds were cis-quiterpenes, such as alpha-caryophyllene, alpha-humulene, and alpha-calacurine. To conclude, this suggests that the compounds could be potential characteristic compounds of each agarwood species.
There are a few factors that could change the chemical composition of the agarwood essential oil, which is the species or origin of the agarwood tree, methods of stimulation of agarwood resin, and extraction method of agarwood oil. In the results, you could see that different species have different composition of chemical compounds. The quality of the agarwood oil is also affected in the resin production by the stimulation method used, either through natural infection, chemical induction, or artificial screw techniques. Extraction method used also influence the quality of the oil. Some techniques used are water distillation, steam distillation, solvent extraction, and supercritical fluid extraction. In a study, hydrodistillation at different temperature of 80, 100, and 120 degrees Celsius is done to extract the oil. In the findings, hydrodistillation at the highest temperature gives the maximum oil yield and have better physical properties. Meanwhile, there are significant differences in the quantity of each composition and type of major components of oil extracted using supercritical fluid extraction compared to distillation method.
Assalamualaikum and hi everyone. My name is Intan Amalia binti Azman from Group B1, and today I'm going to give a conclusion about analysis of chemical compounds of agarwood oil from different species by gas chromatography mass spectrometry GCMS. In conclusion, we have successfully learned how to handle and identify various chemical compounds using gas chromatography mass spectrometry GCMS, analyze different species of chemical compound of agarwood by using gas chromatography mass spectrometry GCMS, and determine the characteristic of aroma between species to identify the authentic of agarwood. We also identify several factors that may result in chemical compositions of agarwood essential oil, including agarwood tree species and origin, agarwood resin stimulation methods, and agarwood oil extraction method. Our results demonstrated that chemical compound composition varies between species.